Before we get started, I just got a question in the chat. Will the meeting be recorded? Yes, it is being recorded, transcribed. We'll share it in a link. We'll share it on our website. So it will be recorded for later if you have to leave early or want to rewatch it. And with that, I think we're at our time, so we'll get started here. First, thanks for taking your time to come learn about our PNP process, and we really appreciate you taking the time out of your day. I know it's valuable. My name's Darren Lockaby. I am the president of DESS USA, and just wanted to welcome you first and start. This is the second part of our 4-part webinar on PNP, which we creatively named. PNP stands for plug and play. And what does it really mean? PNP is really a process to allow dental practitioners, dental professionals, dental labs to mill custom abutments inside of their laboratory and inside of FDA compliance by utilizing our validated workflow process, and you basically piggyback on our FDA clearance for this. It is a validated process, so it has six particular steps, and as long as you are working inside of our partner validated members in each one of those 6 steps, you basically can in a very regulatory cleared way mill your own custom abutments in-house utilizing our 510K. Again, you just have to follow the validated process. It's a recipe. And it allows you all the benefits of being able to control your restorations with your patients and your customers. So in the first webinar, we focused on the first portion, which is data capture. Is intraoral scanning. Our partners at Medit, one of our partners on the iOS side, Medit, provided some information about how to data capture with DESS scan bodies and utilizing libraries to start the process of being able to design and mill your abutments. In today's series, we're going to focus on the CAD portion of the PNP process, and we're excited to welcome another great partner of ours in exocad, and Ben from exocad will be sharing some tips and tricks and how exocad works, and specifically with DESS libraries to help you design and get the optimum products outputs in your abutments. We're also joined by our own Ki Kim, who is our director of technical support here at DESS, and he'll walk you through our DESS libraries and how to utilize them and download them. So nobody wants to hear from me because I know exceptionally little about any of the stuff they're going to talk to you about. So I'll be quiet and mute my mic and take me off camera. And I want to turn it over to Ki to take you through the first portion of the webinar. But once again, we really appreciate you joining us. Much thanks to you for taking time out of your day. All right, Ki, it's all yours.
All right, thank you. Hi, everyone. My name is Ki, and I want to share my screen first. Can you see my presentation, PPT? Okay. Yeah, thank you for joining today's webinar. So, Darren already mentioned DESS PNP regulation. We have, let me see. Okay, the 6 steps. I'm going to cover only today's FDA PNP library part. So I'm going to walk you through the FDA PNP library processing, including how to download and install the DESS library. Actually, I said it's install, but most likely copy and paste process. Okay, and so Darren mentioned the PNP, but if you want to know the PNP more, then you can go to our website and scroll down, and then you can see the PNP workflow. So you can click the instruction and then PNP workflow. You can read all the instruction, and also Darren already covered this webinar, the first webinar. So you can go to our YouTube channel, so you can watch the video too. Okay, let's go to the DESS exocad library. Okay, DESS has the 8 library category, and I will show you. So it's a pre-milled, and then angle base and straight tie base, C base, ellipta base, and then a direct MUA or direct SR uniabutment, direct Straumann SRA or Synocta, and then model creator, and then the peak photogrammetry library. So when you click the download button, then you will pop up the another windows, and then you can put your email address and then click download. Download file will be started, and this is a pre-milled, and then this is a angle base. Angle base and tie base has a 2 versions, semantic gap version 0.02 and 0.045. And now DESS Spain, our manufacturer, is developing the new version of the semantic gap version 0.045 to achieve improved crown fitting. So for a moment you can use only 0.02 is better right now, but sooner or later we're going to let you know once new version 0.045 is ready, then you can use it. And then straight and C base, and then same thing, ellipta base, and then direct, and then photogrammetry, and the model creator. And there's another tools, the library find the tools. This is you can download this specific file only, but so far no one used this one. It seems complicated, but actually you can follow the step by step, selecting the appropriate option. So if you want to learn more, then you can contact me, then I can show you how to use it. Okay, so once you downloaded the library, you have to copy and paste them to the appropriate folder. So I want to show you how to find the implant folder. Go to your desktop and then find it, exocad DB 3.2. I use a 3.2, but somebody use a 3.20 or 3.21. Then mouse right click, and then you will see the pop-up menu, and then you can click the open file location. This is easy to find the file, location, because distributor installed a different, way. So that's why, this way is easy to find the right folder, okay, location. So then it says, File Explorer window will open. So go to the up arrow. You can click the 2 times, such as first, and then second. Then you will get this File Explorer. So find it the Dental CAD app. We can go into the Dental CAD app folder. Then you can see the library folder. Go into the library folder. Then you will see there are several folders. You can see the implant folder and then model creator folder. So at the implant folder, you can copy and paste it, the implant library, and then model creator, you can copy and paste it, the model library. So I will show you. Go to the implant folder, so you will see all the DESS library files there. And then go back, and then go to the model creator folder. You will see and then go to the implant folders one more time, and then you will see all the library, model library folder. Okay. So you see that we have 8 different category. Okay, pre-milled, angle base, straight tie base, C base, elliptabase, and then direct MUA, and then model creator. So you can see, primitive blank. The DESS library format is a DESS hyphen, and then AS means it's Astra EV, and then pre-milled. It says what types of the library. So if go to the straight tie base, then you will see the Astra EV and then tie base. So you will see like this way. The first letters, the 4 letters ASEV is implant brand name, and then next one is a library type. So we have this chart. I'm going to upload this chart to the Teams.
Yeah.
Okay. So so there are the name Biomet 3i, for example, is a DESS hyphen 3i CE is a certain, and then OS is osteotype. So you will see this one. Okay. So once you go to the once you download it, our library, and then installed, then in the ExoCAD you'll see that this windows to align the scan body and scan jig. So this stage actually 3 portions. First portion is like what types of implant, okay, and then you will see the the implant system. So for example, pre-milled blank is Nobel active, and then pre-milled blank, and then once you select, and then you can go to the next step. Size, it's MP is a narrow platform, and then type of scan body is intraoral scan body. And then third portion is you can choose right part. Which part? This is a pre-milled blank 10 millimeter, 61.041 is Nobel active NP narrow platform. Okay, so then you will see like this window. So then you can align. Okay, and next one is we have 11 third-party scan bodies included in our library. So ELOS scan body, Atlantis scan body, and then anti-trading, and Modantica, and True Abutment, and a PRIT. There are 2 types, okay? Peak style blue scan body, and then metal scan body, and then Straumann metal scan body, Straumann mono peak scan body, and then even Seric scan post, and then Seric. This means that you can use the DESS library even for the, including the other branded scan body. So you can design with our part. So this step I'm going to skip because it's a Ben's going to present how to design the abutment, and then I'm going to give you the answer or any question for answer, and then also Ben can help you to the answer the question. Okay.
All right. Thank you, Key. Thank you, Darren. Welcome, everybody. My name is Ben LaRoche. I'm going to start sharing my screen. And is everything good, Key? Can you see it?
Yes, I can see you.
Perfect. So welcome, everybody. So we'll just get started right away. First thing is, for those of you that don't know, what is ExoCAD? And yes, we are part of Align Technologies. The acquisition happened in 2020. And basically, as you can see, ExoCAD is kind of the nucleus of everything, in the sense that once you've scanned, that's great. You've got a digital file. What do you do after, right? And if you want to manufacture, well, how do you create that design and then get it manufactured? So we're kind of in the middle of both sides. If you scan and want to design, and or just design and then send to manufacturing. So with that in mind, our big advantage and the big following that we have is because we truly are hardware neutral. So as ExoCAD, our big quality is that we're not particularly linked with the hardware, right? We work better with the iTero scanner because it's our parent company. It's owned by our parent company, but we also work with all the different scanners out there. As long as they want to work with us, we work with them. And it's always been that way, and we're hoping to keep it that way. So for those of you that don't know who I am, I'm the Canadian sales manager for exocad, but I also do application support. My background, I'm a 20-year lab tech and got into CAD/CAM in 2003. So back when there was no support, no training, and you kind of had to figure it out on your own on a lot of different things. So it's a field that I love and I'm really passionate about, and I love just learning and growing with all the advancements that have been happening. It truly is an exciting field. From there, in exocad, as I said, we work with pretty much anybody that's willing to work with us. So all these scanners are fully integrated with us, as well as on the back end, all the printers and mills. I apologize for the raspiness. Just my throat's not doing too well today, so I don't know why. It's not supposed to happen during summertime. So from there, once we've talked about all the integration, everything that happens with that, and truly those are going to be the key components if you're just getting into this, is what technology do you want to get, and how does that integrate with all the different pieces you want to get. So from this, we're going to jump into just the abutment design because Key teed it up so well and kind of explained how things work. Now, the prerequisite to this is knowing what exactly you're doing. So the difference between a custom abutment and a screw retained crown, and also the components. So as complex as that might have seemed, the description of all the different options and components and all that stuff, I can validate and completely confirm that once you get into it, it really is like Lego parts. Only certain parts fit on other parts. Once you know the implant type, from there, what scan body was used, and then what components are you trying to put on top of that implant for the restorative side. Once you have that, you just kind of, it's process of elimination. It really is process of elimination. So don't be intimidated. I know it looks like a lot of options, but it's actually pretty straightforward once you get going. So with that in mind, let's get going. So what I did in this case, I'm doing a very simple case, anterior case. And the way we define it in exocad is we have a few different options. So here I'm doing an anatomic crown in zirconia, and then I'm going to be doing a custom abutment in titanium. And from there, what I have to tell it is, am I using a scan body? Is there two different scans? So one scan for my scan body, one scan for my jaw, or are they all in one scan together? Or if I don't have a scan body and I'm just using the tie base. That last option is kind of a fail safe in case they didn't take the scan body, they don't have anything. In this case with DESS, it would not apply. You have all the components you need. So you're perfectly suited for a very accurate workflow and accurate predictable result. From there, I'm just clicking on design, which will bring us to our design window. And this is how it starts. So here I have my scan abutment, and as you can see, this one's pretty deep. And I've got, luckily I have, and for those of you that work every day in this stuff, I've got a very rare case where my tissue is fully scanned all the way down. Very often you're going to have just kind of the outline at the top. In this case, I've got a preconditioned tissue, which makes my life very easy. So Key has shown you how those libraries can be manually put into our system so that you have access to all of them. And as you can see, there's quite a few options. Good news is, as soon as I click on this little star here, I've added it to my favorites, and it's always going to be at the top. So if I wanted to download them, if I don't have them in my system, I can go to download more libraries. And this is kind of a more automated way than what Key showed you if you're downloading them manually. So as long as you have a license that's on maintenance contracts, so active contracts, so flex licenses are always active, and perpetual licenses, it has to be within that first year or if you've renewed. So here I can jump to all the different libraries we have, and I'll just scroll right down to DESS And then from there, I can view all the different libraries, add them to my list. And then once I'm done, it will download and automatically position them in the right folder. So you don't have to remember all those different folders if you have a valid license. If you have an expired perpetual license, you will have to do it in the way that Key described at the very beginning of this webinar. So you have options, and either way, you can get this done. So from here, I'm going to pick the library for the scan flag here. And it's really important that you know what scan flagged, how it was used. You cannot kind of interchange them. You can't use a different scan flag library or scan body library than what you have in your actual scans, because it will completely change the orientation and also the height, if you will, of where that seating surface will be. So in this case, I'm going to go, let's go DESS intraoral, and let's pick whichever one we want. Let's go engaging, obviously, because it's a single unit. And let's go here. Now from here, I see a nice little red dot, and I have to find that exact spot. Now I can rotate this by holding down right click and moving it, just like I can on the screen. Same controls, and I can zoom in, zoom out. I'm just looking for that exact same spot, which is right here. And then I can see that it's a perfect match. If ever something is this deep, so the software itself, just so you understand kind of if we put our mind into how the software thinks, it's actually looking to match this whole geometry. So sometimes, let's say this scan was all one scan and this was embedded and I didn't see everything, my match might not be ideal. And that's what this slider is for. I can move this up or down, and this is my way of telling the software, hey, don't consider the bottom here, right? Because I can't see it, so you won't be able to match to it, and just consider the top portion. Now, obviously this is, perfect setup, so ideal situation. So you can see I have 0 differences. It is a demo case. On a real live case, you're probably going to see discrepancies around the corners, wherever there's sharp angle. And the reason for that is not a fault of any kind other than just different technologies. So this right here, I hope everybody can see my cursor. This right here is a 3D drawn geometry. It's actually drawn in a software, so a 90-degree angle will be a perfect 90-degree angle, no rounding, no anything. When there's scanning involved, we're talking triangles, and then those are linked together. I don't want to bore you with details, but there's always going to be some micro rounding, right? So it's normal to see discrepancies on corners. What you don't want to see is a discrepancy on flats. So the top and the diameter or the radius part of the scan flag is the most important. That will tell you that it's matched properly in height and there's no variation on where it's positioned. Once we've got a perfect match, we hit next. And now you see it's replaced everything and put in a representation of that tie base. So here, what the software is looking for, let's bring everything back, is just my, I'm trying to summarize this in the best way. What we're going to be doing here, just so you don't overthink it for an abutment, is we're drawing our limit, drawing our lines, and then we're establishing a crown, and from there it's going to give us our shape. So right now what we're doing is we're putting our margin line for the emergence profile from the seating surface of the implant and that tie base all the way up to where we want our margin line to be for the crown. And that's all we're doing. So we're defining that emergence profile limit. So when I'm designing this in real time, I do this very quickly here because you're going to see these steps repeat themselves, and I have the option to fine tune them later on. So I'm going to go through step by step, but normally I would do this a lot quicker in real time. So don't overthink it. Here I was on detect, so I just need to put 4 points, and then it'll just give me a line. Now, obviously I can tweak this. I can also come here and do correct draw, and I can add remove points. So I can either drag these down or completely eliminate points if I want. So this one, I'm just holding down left click and then right clicking away. And I can do the same all around. And I'll try not to rotate too quick and move too quick to not give anybody nausea, but I can move these as far down as I want. Now, this is very much a subjective thing. Some people really want them deep, especially on anterior cases. Other people will want them flush in certain areas to the tissue. It really is subjective, and this is where knowing what your restoring clinician prefers is important. If they are planning to laser the tissues or suture them in any way, shape, or form, they're probably going to say, expand that as much as you can, give it the ideal shape. If not, they're going to say, all right, I want it to be the least amount of pressure possible. So these are all things that you need to know. If not, you just go with a broad generalization, which is what I found to be anything premolar and back, 1.5 subgingival on the buccal. And for anterior cases, normally about 2 millimeters subgingival on the buccal and flush with the tissues on the lingual for both, with a transition on the mesial and distal. The idea being in the front that if there's any form of tissue resorption, you're not exposing the junction. So here I've just given my limit, and then you'll see the software automatically identifies the mesial and distal. I'll try and back up here while it's doing its thinking. And then it gives me a tooth suggestion. If I'm showing this to the patient, I'll have True Smile going if they're seeing this in any way, shape, or form, so they don't panic and see a yellow tooth. And as you can see, it just gives me a quick suggestion. And here, I can adapt this tooth very well. I'm going to rotate this to a better view. And I'm going to make this my fulcrum point. So now I can move this up, over, whatever I want to do. I'm just positioning a tooth library at this point. That's all I'm doing. I can tilt this. So this is not my final crown. This is just positioning that tooth library. Then move that over. And then we have sliders for tooth anatomy. So for people that really, you can get as many tooth libraries as you want. So here I can change this to whatever one I want. But I want to show you another option, and that is with just this slider. I'm trying to not move too quick here. Yeah, I can change the shape to more closely represent my other tooth. And again, remember, I'm just positioning a tooth here and doing some rough positioning. If I want to make this narrower, I can. Obviously, this is a bit of a complex case because if I want to follow this same dimensions as this central, I'm going to leave a huge diastema here. So this is one of those ones where artistic value would come into play. So let's call that pretty good. My job is not to make this as beautiful as possible. I don't do this every day anymore, whereas you guys do. Now, I would spend a lot of time designing this crown if I know I'm going to do concurrent design. And what I mean by concurrent design is in one file, in one project, having my abutment and then my crown that's going to go over it. So my subentable crown, or if I'm doing a screw retained. Now, if I'm just going to do the abutment and have that manufactured, and then we're either going to scan or position the abutment in the jaw and then scan that and then do the crown over it, I would do a different approach. In this case, I can do a concurrent design. So I would probably spend a little more time, right? And I can also bring this in. Now, if I want wear facets instead of how it's adapting right now, I have two different options. So if I do cut anatomy, it's going to create wear facets. I can hide the show distance here. So you can see it actually cuts away that, or I can say morph anatomy, where it will try and keep the proportions of the tooth normal, but move it out of occlusion. So if I hit next here, All right. And now what it's going to bring me is actually where I do my emergence profile. So I'm going to hide my scan just to show you a little better. I can even hide my antagonist. So what we're looking at here, I move this in the center, is this portion here. If you look, I can actually move and make this more convex or concave, depending on which way I move the slider. And think of the bottom and top angle as my slice right in the middle of this emergence profile. So see if I go top angle, and then I'm trying to create my ideal shape here. I can also come in here and freeform this. So I can actually add certain areas. I can make this bigger on my own in specific areas. Here, I can also go and adjust how those handles are. So remember I spoke in the beginning of if ever we want to put compression on the tissues. So when you see them pink like this, it's going to follow the contour no matter what I do. If I go straight up and down, it's going to go straight up and down, but it's going to follow the tissues. Whereas if I turn these green by clicking on the circle underneath, now I can go as far out as I want and create that ideal shape. So I have a ton of freedom here. And then if I want to follow the contours instead, I can do that. I can bring these down. I can add handles and then bring this down. So again, kind of whatever you want your canvas to be here. You can create something as artistic as you want or as streamlined as you want. Now, when I hit next, this is just telling me that basically I'm violating limits. So minimum thicknesses. So let's see, I didn't read that properly. An emergence profile height. Okay, so I'm too high on my emergence profile. Probably because this is embedded a little too far. So I'll just bring this down. And let's hit next. Yep, there we go. So it will warn you if you're exceeding the limits for manufacturing of any kind. And as you can see, I've not done the ideal crown or anything like that to go over it. I am no longer the professional I was, and I'm counting on you for the help. So here we can see where that screw channel is, hence why we do a cementable and not a screw retained, right? So here I can freeform my tooth, reshape it. I can hide this screw channel if I want. So now I can really spend some time and make this as artistic as I want. I can go aggressively. I can create different mamelons if I'm going to cut back. I can expand certain areas. So if I go here. So a lot of different options here. And if I hit adapt, this is where I cut away. So if I have a virtual articulator where I have all my movements and I've registered my jaws, it will do the dynamic occlusion. If not, I have static. And then once I'm happy with that, I will move next. And here, based on my tooth design, it's asking for the post axis of my abutment. So this will be the angle of the post. So it's set by default to go to 0. If I want to move this back, what I need to consider is how much what I call real estate there is. So if I angulate this back, and I'm going to go from a profile view here. Come on. There we go. And I'll move this here. See, if I move this back, I don't have much room, which means I'm going to have a really short abutment. Whereas if I leave it straight, I have a ton of room. On a cementable case, I would leave this straight unless I need to correct some angles. Then I would try and lean it back, but not enough that it would be too short. So anything below 4 millimeters would not be great for cementable. So here, I'll just hit next. And then it's going to create the abutment design based on that crown design. So here, let me go back to the front view. Right, so if this was the upper, it would be something like this. For design purposes, very often, I will rotate this and look at it from here. And I can add that as a custom view. So if I want this to be a view, I can add a custom view. And then whenever I lose myself, I can come right back to this. So here I have a handle where I can make this shorter or taller. And you can see this is where normally when I'm designing this myself, I would go almost next, and go to this step, because here I can go back to all the previous steps as well when designing my abutment. So I can actually come in here and redefine my margin line or my emergence profile limit. Or I can go back to my top where I can create any type of shape I want, add handles. So how much I want of that shoulder to be present, how much of a taper I want. So, and I can add handles anywhere here. Here you see this little bump. That's because of the minimum thickness for the tie base portion of it. So here I said I was doing zirconia. If I move this out, it's going to thicken the base as well. So depending on the handle I'm grabbing, I can move things out, in, and create whatever shape I want. So by default, this would be anti-rotational already, for those of you that are worried about rotation. And then I can jump back to my abutment bottom. Now, for those of you that are concerned about this little lip is based on materials. And if you remember in the very beginning, we said we were doing zirconia here. So what we need here, this is the equivalent of margin reinforcement or horizontal reinforcement on a crown. This is for manufacturing. If I had a really, really sharp, if I'm doing a pre-mill or something in a material that is of metallic, so cobalt chrome, titanium, anything like that, I can go into a sharp edge. But zirconia, we mill it in a green state. When you mill it in a green state, it's like chalk. So if there's no margin reinforcement here, you can make this into a sharp edge, but then it'll chip everywhere. And then you'll have kind of an unfinished finish line and something inappropriate for bacteria and everything else. So this is where I can change this. Now, if you're doing zirconia, I do recommend leaving that there as a conservative approach and then refining it in its green state. I used to do it under a microscope. If not, your crown will seat right there and you'll just have this little edge. So it's not going to make or break anything. It's just if that is something that is a nuisance for your eye, that is how you get rid of it. And from there, now I have an abutment design. Everything's good. I hit next. And this is where I can go from something completely passive, no undercuts, no anything. And if I'm too aggressive, I can actually ruin the shape and create undercuts. So you have to be careful here. Freedom is a great thing, but also can be dangerous if you don't know what you're changing. So here, if I just do a light smooth, it's great. If I go super aggressive, I can completely undo my shapes. So I would say don't overthink it too much, right? If you are already cut back properly and you have enough support, everything's good to go, then just smoothen some small transitions to make manufacturing a little easier. See, if I just go here and very lightly smoothen this, And don't worry, this finish line is protected. Everything is protected underneath that margin line. And now I'm good to go. So I can hit next, and I've got an abutment. So now it's just trying to finalize. And you can see right away, I can go in and design my superstructure. The superstructure, and this is why in the beginning I said, let's save a scene here. This is why I said if you're going to do the crown all in one case, you'd spend a little time on that crown placement. So here we'll just let it finish saving. And then when I go next, it's going to grab exactly what I use as my crown design. And position that over the abutment. And now I'm just designing a crown as I normally would. So just letting the software do its thinking here. And there we go. So now I'm positioning that crown over the abutment. So it grabbed my crown design. And because I have it set to basically integrate directly into a mill, it's already looking for a blank to put this in. So I can send to the mill. So I'm going to cancel this out. This is why it's thinking right now, because I'm actually not linked to anything in hardware. I don't, my computer is just in my office right now. So this normally would be done right away. We'll get there, guys. And then I want to show you one more thing as soon as it's done. It's processing here. There you go. So now it's saying, hey, do you want to put this in a blank? Which I don't. I'll hit OK. And then if I go to expert mode, I can also, what if I've changed my mind and I want to do a screw retained instead? So I can actually go here and delete my merged parts. Right click. I can switch implant connections if I've decided that I picked the wrong tie base. Or alternatively, I can also go to implant type and see change that from a custom abutment to a screw retained. I'll click OK. And then it's going to backtrack only a few steps. Turn back on my wizard. So now we're at the bottom again. And that, again, that's just for the emergence profile. This is for my screw channel. I will hide the antagonist to make it a little easier for you to see. So if I didn't have much of a tooth here, I can put the equivalent of reinforcement for the screw channel. In this case, I don't need it. So I'm just going to click next. And in a few simple clicks, I've gone from a custom abutment to a screw retained. Now again, my crown design should not be as good as yours. I haven't done this in a few years, and you guys do this every day. But the software itself is very intuitive, very easy to use, very easy to learn. So translating whatever you've been doing with your hands into digital is super seamless and quick. It's a question of just learning the tools and moving forward, and then grabbing whatever's in your head and making it the work of art that you want. Obviously, I would not have done a screw retain here because of the screw channel. I would have had to angulate this back. But you get the gist of it, and I wanted to show how easy it is to transition from custom abutment to screw retained or vice versa without starting the case over should you change your mind or should somebody change their mind while you're designing it. So on the design portion, that is the end of it. I'm going to go through the rest of the slides, and then I'm going to leave some time for the Q&A. Unless you guys wanted me to go over anything specific before I go on with the rest of the PowerPoint. So I'll leave a few minutes here if somebody, maybe a couple of minutes just to see if there's any questions on the design portion that I can go over.
Awesome. Thanks, Ben.
All right.
Going to open it up for Q&As for Ben and Key, either one, and then we have a prize giveaway.
Well,
here
first,
shortly.
Darren,
Yeah.
I don't mind. I don't
Yeah.
mean to interrupt. I'm not quite done the PowerPoint, but I just wanted to make sure. I wanted to make sure that in the design portion, if there's anything anybody wants me to go over, I can actually go over that. If not, I'm going to shut this down and go through the rest of the PowerPoint.
My fault. I will be quiet again.
No, I was misleading, Darren. I did it on purpose. It was a trap. All right. Well, I don't see any questions. So what I'll do is I'll continue with the PowerPoint. And we are. And let's go back to this. There we go. So for those of you that don't have ExoCAD, aren't sure where to start, basically what I showed today was just the core version along with the implant module. So you can get just the core version and then add on whatever modules you want, kind of the a la carte approach. If it's your first kind of foray into this, you're going to be recommended probably bundles based on your needs. There's a reason for that. It's not an upsell technique. It's basically these are way more of value than if you were to buy the core version and add every single module a la carte. If I were to compare this approach to the ultimate bundle, you will save 55% on the cost on average, right? Sometimes more, sometimes less, but if I were to give you an average, approximately 55% if you go with the ultimate bundle versus all these modules in here added on one at a time. So what that brings up is basically that you have to think of what is your short-term goal and your long-term goal, right? So if you're just getting into this, what do I need right now to accomplish to get a quick ROI and get the wheels going and kind of make sure that this is going in the right direction? And then where do I see myself going in 2 or 3 years so that it's not a bill every time you call and you're adding more offerings or more value to what you do. So it really is very simplified for us. We have a ton of options. So if you don't know what you're looking for, that can seem complicated, but that's where the reselling partners, the distribution partners, and everybody is there to guide you. So as long as there's proper communication, you're going to be taken care of and you're going to come out of this winning. It's going to be a beautiful thing. And it's just important to know what options you have. So that's the goal to this. And also to let you know what I've shown you today and how you can replicate it. I do want to do some little, if you enjoyed this and if you wanted to learn more, just a little more kind of promotion on different events that we have. So we have an actual training center or training facility at ExoCAD headquarters, which is in Wakefield, just outside of Boston. And we have all these courses already scheduled. So if any of these interest you, just scan that QR code right there and you can register for these. They're of great value. They're going to help you. And we're there to make sure that anytime you have faith in our product, we want to make sure that it's a win for you and we're trying to help you. So I'll leave this up for just maybe a minute. We have different subjects and we revamp this yearly. So this really is just kind of different offerings that we have at different times. We have also reselling partners that will teach you on your modules, on what they've sold. There's a ton of options out there to learn. So training is never an issue and learning is never an issue. And then lastly, we have basically our blogs. So this is just social media to keep you in the loop, tell you of everything new that's happening with us, kind of stay on top of things. So you kind of are in the know with everything. So we have news bites, which is monthly on all of our events, anything that's noteworthy from us. Whereas the blog is basically everything that is gathering and how can I put it, where we've been, what we're doing, keeping you kind of in the know of where we're at. So there's a bunch of different options here. You can use these links and register for them. It will ask you also if you want I think it's the newsletter when you're downloading that library, as I've shown you in the download manager in the software. So there's many different ways to stay in the know with ExoCAD, and we recommend it. So now we're at the Q&A part. So hopefully there's some questions, and hopefully I have the answers for them, or Key has the answers for them. And I see we're about 10 minutes ahead of schedule, so.
Awesome. So now I can jump in, right, Ben?
Now you can jump in there, and I apologize for that.
No, my fault. As folks are thinking questions, we'll certainly take them until the time's up. We do have, a kind of a raffle prize. Janelle, if she's on the line, I would invite her to come on and pick our raffle winners. Both DESS and ExoCAD have donated a prize for those of you, just as a small appreciation. So Janelle, are you on?
I am. Can you hear me?
Yep.
Yep, we can hear you fine.
Hi, everyone. Thank you for putting the webinar together. This has been randomly picked. Julie would normally be here today picking these. She's our webinar host, but she is out. And the two people that we have chosen is a lab by the name of Renew. And we have Blake Scott. So what's going to happen? Yeah, the email that you guys registered with today, we're going to use that, and you will be hearing from Miss Julie when she returns into the office next week, and we will send out those. I don't know if they're certificates or if it's an email with the coupon code for you guys to be able to use it. And thank you again for joining us today. We really appreciate it.
Awesome. Last chance, questions. Certainly want to make sure. I guess, Ben and Key did an outstanding job explaining, so no questions.
That's how I'm taking it as well, Darren.
That's right. I'm going with that. Awesome.
All right.
Well, at this point, we'll give you 7 minutes of your life back. Again, want to thank you for your time and attendance. I know it's really valuable. Ben, thanks for joining us. Really appreciated your expertise, and thanks for your partnership of both you and ExoCAD. Really appreciate it. Awesome.
Thank you as well.
Everyone have a great rest of your week and weekend, and we'll look forward to seeing you on part 3 of the webinar here in a couple of weeks.
Right.
All right.
Thanks.
Bye, everybody.
Thank you.
Bye-bye.
Thanks,
Bye.
everyone. Bye.